Museums are really the archives of scientific knowledge. We think that the future of meeting the needs of 21st century biology will be about frozen tissues, life on ice. The Smithsonian has just built the largest natural history biorepository in the world. Biologists are going to be spending a lot of the next few decades sequencing the genomes of many kinds of life on Earth. We're in the field out at Edgewater, Maryland, which is the Smithsonian Environmental Research Center, and we're here to start working out the methods for how you put life on ice. You might ask, so why do we do this? Well, as a scientist, the main reason is that I want to understand the history and the diversity of life on Earth. For 300 years, we've been studying the morphology of animals, the behavior of animals, the ecology of animals. What we've discovered in the last 20 is that all of those things leave signals in their genomes. So there are a couple of really hard problems we haven't been able to solve with classical data, and we think that genomic data is the way to solve all those problems.
Got him. See? And he's in there. This looks like a leucalgae. Yeah.
That's one. We'll be catching spiders live and then plunging them directly into liquid nitrogen, which, by the way, is a very fast and painless way to go. It's instantaneous. Ready? So this is sacrificing the spiders. You hear that?
Boiling away.
Why care about spider genomes? It's two obvious reasons. They're silk and poison. They have some of the most elaborate and precise poisons of any organism on Earth. They're widely used in neurobiology research, so that you can see the mechanism of how the poison affects cells, let's say, in a human body. So we think nature is a library of solutions that are waiting to be discovered.
Museums are repositories of all sorts of information that people have used in the past and haven't used yet. So we're adding to it, to a museum collection in a different way than has been traditional. And basically, museums will have specimens in ethanol, they'll have specimens that are dried in pen, they'll have specimens that are in drawers, and they'll have specimens that are in the biorepository in liquid nitrogen. So to me, it seems a normal thing for a museum to be doing, which is to be adding to its collection.
The liquid nitrogen tanks hold tens of thousands of samples at minus 190. At the moment, liquid nitrogen is the gold standard for long-term, and by long-term, the Smithsonian's in the forever business.
Now we're starting to centralize our frozen tissue collections. So we're somewhere between 200,000 and 500,000 samples. The reason we do this is people like to do genomic work, they do phylogenetics, they do toxicology work with our samples. So researchers request samples, and we actually go in and we pull samples out, we cut a small piece of it, and send them out to the researchers.
Every time science jumps to a new phase, the museums will follow it, because technology of doing genome sequencing is advancing rapidly. By building a library of frozen tissues where you can do genomics of life on Earth, we'll be doing what museums have always done, which is to concentrate life into a collection that will support research.